to Tech Transform. In this video I'm going to cover about Pandas data frame. In my last session I have covered about uh, Pandas series. Let's continue with the data frame in this, then we are going to complete the entire Pandas concept. So data frame is nothing, just a representation of tabular structure like row and columns in table or in Excel worksheet. So it can contain, you can tell also, you can tell like that also it's a collection of series objects also. So let's do hands-on and try to understand how to create data frame. Basically you creating data frame is just nothing, is similar like table structures having columns and rows, column headers and all those. Let me open my document. Yeah, so to create there are various way to create data frame. First we are going to take a data with dictionary. So this is a dictionary, and inside each dictionary, each key, the value is a list object here. Just try to make it look good. Yeah, so here you can see we have a dictionary called data. Inside that data we have three keys: state, year and pop. Pop is nothing but population. And state, we have list of data for states. Years, we have list of years. Populations, we have list of populations. So these all the data inside this list should be number should be same, items should be same inside all the lists. Execute this. So this is nothing but a dictionary object in Python. Dict. Okay, now we have to convert this dictionary into data frame. The syntax is frame is equal to data frame, then we have to pass this data variable, so it's converted. Okay, we haven't import that dependency packages. We have to import. For that, import numpy as np, import pandas as pd, from pandas import series data frame. Now try to execute this. Let's try to create a frame is equal to data frame data. So we are now able to convert into a data frame. See how a dictionary looks like. This the key of this dictionary object become the column, and the value is becoming the value itself, and this is the default index we got. So if you're not providing the index explicitly, it is going to take default index starting from 0. So that's how this data looks like. Using dictionary object we are able to create data frame. Let's say this column is in order. In what order we have created? Let's say I want to this state, year and pop. This is what your dictionary keys is in the order, and it's according to that order is created here also. Let's say I want to change the order. For that, frame is equal to data frame. We have to pass the data object, then columns is equal to list of object. The first one we can say I want to declare first year, then state, then population pop. Now check what is inside frame. So see, we got that. So we are able to change the order of the columns also using this syntax. Now year is coming first, state is coming later, then pop. Okay, let's say we have to, this is the default index is there. Let's say we want to give explicitly, we want to assign some index. For that, same thing, one more parameter we have to add, index is equal to, let's copy from here itself. We are basically changing 0 from 0 1 2 3 to 1 2 3 4 in text format. Execute that, run again. See, this index was 0 1 2 3 4. Now we assign the index 1 2 3 4, so it's took 1 2 3 4 5. So we are able to change the index also. Okay, if we want to print all the columns, we can use frame dot columns. It will give you all the columns inside that. Let's see, if we want frame dot index, it will give you all the indexes 1 2 3 4 5. If you want to access any particular column, let's say I want to access state. For that we can use two syntax, but we can achieve the similar result. Frame, either we can give like dictionary type or dictionary type syntax state, and we can print all the state, see OU OU OU, Nevada Nevada, index will default will come. Or again also we can use frame dot state also. See the same result. So by having these two syntax, we can access the column values. Okay, if we want to access a specific if we want to, let's say I want to access this the second row. For that we can specify frame dot loc, and we have to provide the location using index. The index is 2, so this is going to give me the second row. So based upon index we can locate actually. So we are able to get 201 OU 1.7. okay. Now check what is, yeah, let's say we want to assign some value. Yeah, let's say I want to assign a column which is not there. For that frame, let's say I want to add new column depth, and I am initializing with a value of 16.5, let's say. So what it will do, it will add this column in the existing data frame. See, we got that. We are able to add new column also with this value. If we are not specifying any value, it is going to take NaN not a number. Also you can do something like this. Let's say you can create a series object. Remember, each column is a series we can treat. Let's say I have a val series. Inside series we have three values. These values and index is 2 4 5. So let's say I want to assign this val series to depth column. I want to populate this depth column using this val series object. For that, what we can do, frame depth is equal to val. So you can see here 2 4 5 2 4 5 index are matching, but 1 2 are missing here. So it will search for the index and it will assign the value there only. If it is not find the matching index, it will replace with NaN. Execute this and you are able to understand. Let's rerun frame again. See, we have two index here in the series object, so it's able to get minus 1.2, but there is no index for 1, so it replaced with NaN. Let's move to next. We can add some more columns like this. Let's say I want to introduce one more column, Eastern. This is currently it is not there, but based upon the existing state name, let's say I want to populate. So this is the boolean expression. Based upon this boolean expression, I want to fill this string. I want to add this new column and fill the value. So this is basically what it is doing. If any state value of that particular if state is equal to Ohio, it is going to return true, otherwise false. So this string column is going to contain true, false based upon this boolean condition. Let's execute this. Sorry, frame. It's not frame 2. Frame here also. Okay. Now check this frame again. Here see we got this. So wherever you can find Ohio, the string column value is true, otherwise false. So that's how we can add columns based upon that existing columns in the data frame. We can populate the new columns and add the new columns like that. Okay, now there is another way to create data frame also with a nested dictionary object. So let's say we have this we have data like nested dict of dicts format, means this is actually a dictionary. Inside this key, the value is itself a new dictionary, so it's a nested dictionary. Let's see how we can use in creating data frame. Control C, Control V. So you can see here we have this pop dictionary. Inside that we have this dictionary, this key, then this key in dictionary, and the value is itself a dictionary. But you can see the outer key, when we are trying to convert this pop is basically population. This dictionary, if we want to try to convert into data frame, this outer keys will become column, and this inner keys means the value of that dictionaries, and it's that itself a dictionary. The key of the inner key will become the index. Let's see this. Try to convert frame 1 is equal to data frame pop. See, we got this. This become the columns. The outer keys become the column, and the inner keys will become the index position. So 2000 is not present here in the first key, so that's why it's replaced with NaN. Apart from that, we found value, so it's replaced. So if we pass to data frame, it will interpret the outer dict keys as the columns and the inner keys as the row indices. If we want to transpose, we can transpose also. Frame 1 dot T. Now it's become, the row become column, column become rows. These indexes become column, and these columns become indexes. So we are able to transpose also the existing data frame. Also we can set their name attribute, and also we can set their index name also by using frame name dot index dot name. We have to give this, then frame dot columns dot name is equal to, let's say I want to frame, okay, let's say I want to give index as a name. Frame dot index dot name is equal to, okay. Now quickly check this frame. So you can see here there was nothing. Now this index, we can say it's year index, something like that. Then frame dot column, if we want to give a column, we want to give a name to the columns, like frame dot columns dot name is equal to state. Now quickly rerun this frame. See, we got this as state. So we are able to specify the whole column name. We are able to give the whole indices name. Now what we are going to do, so that's all for this particular understanding the data frame functionalities and all those having different operations. Let's do a case study where I'm going to do a case study based upon this population data, and we are going to perform various operations on data frame. For that I have a separate document. Let's see. What we are doing here. Let me copy. Okay, Control V. What I am doing here, I am creating a years list using range function. So it become 2014, 15, 16, 17 excluding 18. So 4 values. I am taking one series object sop1 pd.series, okay, and giving index is equal to years. So 3 series objects I am taking. I am executing this. If you want to see, you can see also. See this years. If you want to see sop1, so this sop1 having all these series object, index are 2014 to up to 2017, then the actual values. Now if we want to, using pandas, we can concate these 3 series. Basically we are trying to create a data frame from this sop1 sop2 sop3 series. So pd dot concat, we are passing all the 3 series objects inside list. So it become 2014. See, this is sop1 sop2 data, sop3 data. Okay, now we want to create data frame using this. For that, Control V. So here the same thing, we are concatenating, and also if you specify the axis equal to 1, what happens? Let's check. Control C. So what it does, it's based upon that similar index, let's say 2014, based upon this it segregated the values and made like this, because we doesn't have any column name here, so by default it took 0, 1, 2. If you want to specify here, you can specify columns names also. Okay, so this is what we have. Let's say I want to replace with 0, 1, 2 with this cities. If you try to give the columns, so for that sops underscore df dot columns is equal to, we can pass like this, sops underscore df. See, we got this. In place of 0, 1, 2, we are able to replace with the actual column name, okay, using dot columns. You can give the names like this also, sop1 dot name, sop2 dot name, sop3 dot name. Now a data frame has a row and column. Now let's create a data frame from dictionaries. We already created that, but let's check this how it is going to, because we are going to do a lot of other operations based upon these examples. I am running this here, Control V. Okay, you can see we have a dictionary object cities. Inside this dictionary we have one key called name. Inside name we have list of names, population, list of populations, country, list of populations. Then what we are trying here, using this dictionary object, I am trying to create data frame. You can see city underscore frame is name London, population this, country England. Okay, we are able to convert it into data frame by using dictionary. Let's say I want to retrieve all the column name. For that, city underscore frame dot columns. Okay, if we want to give the column index, right now the column index is by default integer index. If we want to give some ordinals, because we have 13 rows, we can create a list. Inside this list we can assign all the values. Now we can pass this ordinals list to index of data frame. Okay, we are creating cities and we are passing index as ordinals. Now rerun city underscore frame to see. See, initially we have 0, 1, 2, 3. Now we have first, second, third up to 13th. So how this is how we can use index, having separate list, and we can create assign some different indexes to data frame. Rearranging the order of columns we can use like this. Right now name, population, country is following. Now we want to name country, population. Let's say I want to give country. I want to follow this order. The column should be printed in this order. So it's become country, name, population. If we want to rename this, rename the column's name, you can do like this. Dot rename means data frame name dot rename the columns is equal to old column, new column name, old column name, q column name, old column name, q new column name. In place is equal to true. This property needs to be true, otherwise it will not work. Now see, we are able to change the, we are able to change this column name. See, let me get back to original. Okay, we have to follow this ordinals. Okay, we have this city frame back with the original state. We can use existing column as the index of a data frame. How? Let's say I want to make this country name as an index itself. Syntax is the same syntax, pd.dataframe. We want to create data frame, cities, the cities dictionary object, columns. We want these two columns, name, population. Now we don't want this country column. We want this index to be, we want the index from the existing columns. Let's say I want the index to be displayed as a country. For that, index cities of country. Now see, we have only two columns and this country become index. Okay, now let's try to access the columns using the LOC and IOLC method, location method. So far we have tried to retrieve the data based upon that column. Now let's try to retrieve data based upon the index. So here again we are creating the same data frame, we are creating the same index cities. Now we want to display this Germany record. So we have three Germany, index Germany, Germany, Germany. We got that. Okay. Let's say we want to, if we want to access more than one location, more than one index, we can pass it. Pass it as a list of different items. Let's say I want to access Germany also as well as France index values. So for that, set data frame name dot loc. Then we have to pass number of items in the list we want. as an index. So we got Germany and French data. Let's say I want to print the population greater than 2000 only. So what we are doing here, city underscore frame dot population, whoever population has been greater than this quantity, this number will be displayed. See, we are able to filter out the results also. Sum and cumulative sum. We can calculate the sum of all the columns of a data frame or sum of certain columns. Let's say I want to sum all the values. So see, it's become name because it's not going to do anything, it's not going to add anything. Population, it's added and given you all the values. It added all the populations from here. Okay, what is inside city frame? Is it changed or not? Let's check. Yeah, original value is there. So we are able to add the any column value. We are able to do that. Let's say I want to add only population. For that city frame we have to access that, then simple dot sum will get the complete sum of this population column. Cumulative sum is nothing, just cumulative sum is if you this, then in next row you have to add these two, then in third row you have to add the previous two, like this. Okay, so see, this is the cumulative sum England, then we can add all those previous populations and do the cumulative sum. So that's how you can get cumulative sum also. Instead of let's say we want to replacing, we want to add a new column value with population. So instead of replacing the values of the population column with the cumulative sum, we want to add the cumulative population sum as a new column with the new cum underscore population column name. Okay, so now we have cumulation population like this. Right now we don't have any value. Let's populate the value. So for that, what we can do, we are try to access this the newly created column. Then because we are try to calculate the cumulative sum on population, we have to find that particular column and that dot cum sum. So this will give us the cumulative sum. Let's print this city underscore frame again to check the cum underscore population value. See, we got this cum population data. Okay, so pretty cool, right? The thing you have to give access columns of a data frame. We want to access columns either dot or either accessing like a dictionary. Assigning new values to a column. If you want to assign new value, we have to do like this. If you want to sort by area, let's say I want to create this. I want to create a data frame. This area, I want to create this. So I have added this area in the existing one, in the existing our city underscore frame. Now let's say I want to sort that this data frame based upon area and in ascending falls. Means what we'll do, it is going to ascending order false, means it is going to sort data in descending order. Let's print this city underscore frame again. See, this area is now decreasing. We're able to sort that also. So city frame data frame name dot sort underscore values, you have to pass on which column you have to apply sorting, and what you want in ascending or descending. This we already saw. Data frame from nested dictionary. Let's say how we can create data from the nested dictionaries. So we have this dictionary object growth. There is a all this country name is becoming key here. Inside this key there is another, the values on again is a dictionary. Inside this dictionary value we have again 2010 2011. So this outer key will become the column of the data frame, and this will become the index of the data frame. How? Let's print this. ZROWTH. Okay, now we are trying to convert into data frame. Let's check this frame, data frame. See, we got that. The Switzerland, Germany, France, Greece, Italy become the columns, and the inside key columns inside key of dictionary become index. We can do transpose also. Okay, now we want to let's say we have some files, CSV files, data is persisting there, and we want to create data frame using those CSV files in the data sets, or either we are doing some work and finally we create a data frame, we want to import the data frame into CSV also. These two things we can do. So Pandas offers two ways to read in CSV or DSV files, to be precise: data frames underscore from underscore CSV, read underscore CSV. This is no big difference between these two functions. They have different default values in some cases, and read underscore CSV has more parameters. We will focus on read underscore CSV because data frame dot from underscore CSV is kept inside Pandas for regions of backwards compatibility. Let's try to access this. I will show you this file where this data is set is there. Dollar underscore year underscore text, it is separated by tab. Work, go inside datasets, dollar, yeah, this one. You can see this is a tab separated. At the top we have columns header, and below are the values. We have to work. We have to finally create this into a data frame object using this CSV file. Let's do this. Okay. So for that, what you have to do, pd dot read underscore CSV. Let's type this better. EXCH exchange rates, exchange rates is equal to pd dot read underscore CSV. Okay, then we have to pass this path. Okay, then we have to pass the separator. So we have to tell on what separator this is going to understand. So we got a tab delimited backwards is T and nothing. Execute this, try to print this. See, we got this. We just saw year average, minimum user ID, year average, min user ID, working days. These all become data frame. So by using read underscore CSV, we can read any file and finally we can convert into data frame. Okay, let's move. What is next? Yeah, here we can say header is equal to 0, names is equal to year, min, max days. We can say that there is no header is equal to z, and we can explicitly say that names is equal to year, like this. So this the name we are able to change. We are able to give names as year, min, max, days. Okay. So this is how we want to do only this. uh, Names is equal to year, mean, max, days, something like this. We can do like this also. So these are some others operation we are trying to do. There is a one more file I have, countries underscore population. So let's check that what is inside this. Countries underscore population. So see, this is what we have. This is comma separated, I guess. Yeah. Separator is actually a space. Okay. So separator is a space. The file country underscore population CS is a CSV file containing the population, numbers of all countries. The delimiter of the file is a space, and commas are used to separate groups of thousands in the numbers. Okay, so these are the you can say we are separating the thousands. Now inside number we are separating using thousands. So how to do that? Copy this. So same thing, pd dot read underscore cav, we are giving the path, not this one. This one. Okay, so this is what we are trying to create a data. First we are trying to read using read underscore csv. We are trying to read this csv file. So header is equal to none because we don't have anything as a header. Name, country, this is country, this is population. So basically these country and population are separated by space. That's why we are telling separator is equal to space. Quote characters we are trying to give. This is we are trying to as a quote characters. So this is going to interpret as a quotation. Separator we are specifying a space. Then thousands we are specifying comma. Based upon this comma, it's going to display. Okay. Because it's contain lot of record, let's print this pop dot head 5. See, we got this China 135925, something like this. China 135. We have given them the column name also, country, populations. Okay, like this we can see how this data was looking. Now we can understand this, what is this data, how powerful the panda is. So we have seen a lot of operations using pandas data frame. So that's all for this video. Thanks for watching. Have a good day. Bye.